Hi, I'm Miss Hearn. Let's get started. We're going to talk about integration by part. We have the integral of u dv equals u times v minus the integral of v du. You can think of it as a kind of a double substitution. I'm going to look at the integral of x squared sine of 4x dx. This problem is interesting because one way to solve it is to use integration by parts more than once. So I'm going to work it two ways. First, I'm going to work it directly, and then I'm going to work it using a tabular approach. We're going to choose our u and our dv. I'm going to let u be equal to x squared, since du would be 2x dx, which is 2x is simpler than x squared. But also because if I let dv be the rest, which you would have to, sine of 4x dx, then finding v is not too bad. The integral of sine of 4x dx is going to be negative 1/4 cosine of 4x. dv is a fairly complicated portion of the integral, but still fits an integration pattern. All right, so now we're going to write our formula. Integral of u dv equals u times v minus the integral of v du. And we're going to make our substitution. So we have the integral of x squared sine of 4x dx is what we started with. U is x squared times v, which is negative 1/4 cosine of 4x, minus the integral of negative 1/4 cosine of 4x times du, that was our v. Now du is 2x dx. I'm going to simplify this a little bit. So this is going to be negative 1/4 x squared cosine of 4x plus 1/4 times 2 is a half. So 1/2 the integral of, and then we have x cosine of 4x dx. So now this integral also fits the common pattern that we see with it. X to a power out front of a trig function, the power being 1 in this case. So we're going to use integration by parts again. So yes, a second time in the same problem. And u2 is going to be x, and dv2 is going to be cosine 4x dx. So to find du2, we're going to have the derivative of x is just 1, or dx. And then to find v, we integrate cosine v2 rather, we integrate 4x dx. The integral of 4x dx is 1/4 sine of 4x. v2 is 1/4 the sine, that's a 4, the sine of 4x. Okay, this was our u2 and our dv2. By the integration by parts theorem, the integral of that will be equal to u2 times v2 minus the integral of v2 du2. I'm going to copy down the whole thing that I had so far, plus, and then we have 1/2, and now this is going to be, remember to put brackets, the whole thing's being multiplied by a half, u2 times v2, so that's going to be x times 1/4 sine of 4x minus, and then we have the integral of v2, which is 1/4 sine 4x again, times du2, which is just dx. We have negative 1/4 x squared cosine of 4x plus 1/2 times 1/4 x sine 4x. I just prefer that order. And then I'm going to think of the 1/4 here out front. So the integral of sine of 4x dx, remember we found before, was negative 1/4 cosine of 4x. So what we have here is negative 1/4 times negative 1/4 cosine of 4x plus c. Simplifying a little bit, we're going to have negative 1/4 x squared cosine of 4x plus, I'm going to distribute this 1/2 inside, so 1/2 times 1/4 is 1/8 x sine of 4x. And then distributing the 1/2 again would be negative 1/8 times negative 1/4 would be positive 1/32 cosine of 4x plus c. So notice that when we got rid of the x in front of the trig function here, we didn't have to do any special integration by parts anymore. And that happened because we ran out of exponents on the x. Basically, our first u was x squared. The derivative of that was involved in x. The derivative of x involves just a 1. So you can imagine that if we had had x to the 4th or 5th in the beginning in our integral, we would have had to apply integration by parts a bunch of times. And so that can get very messy and it's easy to make a mistake. This comes up a lot when you have forms like this, x to the n times a trig times a sine or a cosine, or x to the n times e to the ax. So you want to keep this idea in mind when you see those formats. So I'm going to work the same problem, x squared sine of 4x dx, and we're going to use the same u and the same dv, but we're going to organize our work in a table. So create a table of 3 columns. It's always the same. You're going to have one column with alternating signs, one column with u and its derivatives, and another column with v prime, or in other words, dv. I've been calling it dv, so let's be consistent. dv and its antiderivative. So what I mean is, in the first column, you're going to start with a plus and go plus, minus, plus, minus. In the second column, you're going to list u and then its derivatives. So in this case, x squared, 2x, 2, and 0. So derivative of x squared is 2x, the derivative of 2x is 2, and the derivative of 2 is 0. You're going to stop when you get to 0. And then you're going to list dv and its antiderivatives. So sine of 4x was our original dv. The antiderivative of that, the integral, was negative 1/4 cosine of 4x. And then when we integrated that, we got negative 1/16 sine of 4x. And then when we integrated that, we got 1/64 cosine of 4x. So now what we're going to do is we're going to move across the table in this pattern here, across and down, until we get to 0. And we're going to multiply across and then add the resulting terms. So, for example, the first product is going to be positive x squared times negative 1/4 cosine of 4x, or in other words, negative 1/4 x squared cosine 4x. The second one will be the product negative 2x times negative 1/16 sine 4x. So that turns out to be positive 1/8 x sine of 4x. And then the next term will be positive 2 times 1/64 cosine of 4x, which ends up being positive 1/32 cosine of 4x. And so if we add these all up, we're going to have the same integral that we had before. Same answer. So, and just put a plus c at the end, of course. So you get the same answer that we did before. I hope you found this video helpful. If you did, please remember to give it a thumbs up, and that will help other students to find the video.